All right. Good morning, everyone. I hope you're having a great time here. Coffee filled up and all that. So, yeah, please excuse me. This is hard. Naming things is hard. Caching validation and naming things. This guy, Phil Carlton, used to be an engineer, or developer, manager at Netscape. And this is probably one of his most famous quotes. And some people actually amend that, because off by one errors is one of them. Either way, bear with me with the name of this talk as time goes by. Anyway, we got a few chapters ahead of us. First things first, some context, this DBAs thing, some fun stories, some stories about scaling out, and some horror stories. So let's get on with it. First things first. So who's this guy? I've been, as Ricardo said, at a travel agency. I've been at digital magazines, visual effects. I've been doing data engineering development, engineering management, development, anyway, a bunch of things. But today, I'll be your DBA. So let's start with that. So who are we? I mean, everyone here in this room today. We're engineers, yes, we are with infrastructure, some of us. Some of us are in software, some of us are in product, and hopefully human. And with any luck, some of us are really nice people. So let's start with that. So about software engineering, what's the story here? Is it about the product? Well, if you don't realize that you're part of a bigger picture when there's a product or a service involved, you're in the wrong place. So let's just keep that in mind. Does anyone know who that lady is? Show of hands or shouting. Right, so this lady here is called Margaret Hamilton. She was in the MIT instrumentation lab in the 1960s, writing the code that took people to the moon. She actually coined the term software engineering. So that thing is old. Anyway, that was the state of the art back in the 1960s and 70s. That is actually the technology that took people to the moon and back. This is called rope core memory, or the other way around. Anyway, basically, if a cable went through a magnet or a core like that, it meant a 0. If it was outside, it meant a 1 or something like that. And on the right-hand side there, you can see a blow-up of how that looked. It was very tedious, very hard to build, but it was reliable. The code in there had the amazing capacity, the amazing size of about 72 kilobytes of RAM, or what we call ROM today. Likewise, this one is a blowout of what we call erasable memory. RAM didn't really exist back then. So through a very complicated system of wiring, you could actually flip those bits back and forth. I believe that's something about 32 kilobits, which would be like something like 4 kilobytes of RAM, and that's all they had. And yet, it was enough to drive a spaceship back and forth. So, yeah, things changed a little bit over time, and we are at the petabyte range. Yottabyte, whatever, comes next. So, back to a little bit of the story. Since this is about databases, we need to talk about SQL. And oh boy, we got it wrong. This thing was created so non-programmers would be able to access and query the data. This thing appeared nearly 50 years ago. Last mission to the moon was in 72. The first standard appeared in 1986, so a long time ago. Some of you weren't even born. And yeah, we got it wrong, because people still don't use that as it was supposed to be. Oh, some context here. A typical day on someone working with databases, most of the time you solve ad hoc problems, meaning automation is really hard. Sometimes you're blessed because someone before you solved a similar problem, so you have something to rely on. But if you're advanced enough in your career, that means you're the first one to try to solve that particular problem. They are very, very specific. And if you're really unlucky, that problem will never plague you again. So you don't have a chance to learn from that. So, rule number 0 of the DBA, because arrays start with 0. What do you think is the most important key on a keyboard? But someone said ask, Control C, Command C, no? Anyone? Space, no. Escape them. Not at all. The most important here is enter, because until you hit that key, everything can change. Once you hit that key, you are fully committed to whatever you entered on your command line, right? So rule number 1 of the DBA, because we started 0, is never trust what anyone tells you. Always double check, always verify. There's a reason for that. Well, most people don't have a full picture of what's going on any given distributed system, and that's also the case here. Talk to your security person, talk to a developer, talk to a manager, talk to anyone in product. They don't have a full picture, and that's a given. Always double check. Rule number 2 of the DBA would be what? The only thing that is constant is change. So in a world that the data is coming in and out, and you need to keep things up to date, all technology is coming by. We just saw a few slides ago how technology for storage changed over time. We're now talking about multiple volumes of data that don't fit anymore in a computer of the size of that. And, of course, there's a rule number 3. Get used to saying no. And there's a reason for that, which we will dive into a few moments. Because, people love cool things, and not all cool things are great. Not for the business, but details on that later. So let me tell you a story about product, right? So product requests a new feature, and then you sit together and you create stories. How are you going to do that? You create your tickets and all that. You assign some points, write some code, and you test in some environment. And then you deploy. And then what? Profit? Yeah, until you get to that. Well, at that point, usually you try to hire or to consult with someone that might have a clue what's going on. So, have you heard about DevOps Narnia? Yeah? Something like that in the front end, something like that in the back end. Menu 1. Anyway, let's just go through this DevOps, DevSecOps thing. So yeah, according to Wikipedia, it's a beautiful thing. It's used as a set of practices and tools. DevOps integrates the automates the work of software development and operations. Sure, it's more like that, right? Beautiful field, rainbow and all that. I actually saw a double rainbow once, but that's another story. This is more like it. What happens there in the back end? You have engineers fighting back and forth to what you do, or what you think is best to solve a problem. Anyway, well, let's talk about technology stacks and expectations management. As I was saying, adding something to the stack always has a cost. It's just not for the engineering team. It's for everybody in the organization. Usually you think, oh no, that only apply to my team or to another team. That's hardly the case. The infra team needs to know about it. If we're introducing a new piece of technology, hardware, software, process, your infra team needs to know about it. It needs to know what to do with it. So there's a lot of challenges in that area. You add a new thing, you need to know which metrics are relevant. We're just talking about the observability here a few moments ago. So how are you going to tune that? What does it mean if a number goes up or down? And how you're going to respond when it fails. Keyword here is when, not if, because things will break. And yeah, this is my favorite. You wake up, You get an alert, you're in your bed, 3 a.m., you're half awake, you look at that, it's just, what the hell does that mean? Yeah, you need to sort it out. So usually you have some dedicated people to technologies. The example here is for databases. Usually developers need to raise tickets, to create users, to do schema changes, and that creates a huge bottleneck because they need to ask the DBAs or your experts to do anything in their behalf. Even to configure pipelines, it's complicated. So what about DB migrations? And I'm talking here about moving that stuff to another data center, to another version, to a simple upgrade. How do you handle all those challenges? Well, schema changes, and that creates a dependency between teams. It's really difficult to understand how people optimize things. And remember I talked about SQL being like almost 50 years old, 40 years from the first standard? People still don't get it because people still use ORMs. And when you do that, you lose all the abstraction. You create a bunch of abstraction layers and you lose sight of what is actually going on your machine, on your system. Well, then again, no one single person can understand or can have the capacity to understand what's going on down there. And monitoring sucks. Let's be real. I mean, if observability wasn't the thing, and we should be driving towards having more and more observability, we collect more metrics. But what does that mean? What these metrics mean? It's a little tricky. Having a separate team of DBA, Dev, and operations is not usually a great thing. In fact, I wouldn't be here today if it wasn't for my team. I'm on an infrastructure team with a bunch of other engineers. And, well, the thing is, our skill set complements each other. So it's not about siloing, but blending and building on top of that. And if you do separate things between teams, provisioning becomes a nightmare because you have a bunch of bottlenecks, artificial bottlenecks that don't really need to be there. Now, let's go to some fun stories. So how DBAs look at developers, that's a little bit tricky because those are dangerous people, very dangerous people. They can bring the whole house down with a single line of code. How other people look at us people from infrastructure? Well, it's something like that. And of course, then there's how developers look at us people, DBA people. Yeah, the red stapler. Don't mess with the red stapler or burn your house down. So what about testing in environments? Well, everyone can test. Everyone has a testing environment, but some people are lucky enough to have a production environment to run that, a separate environment. Yeah, it's true. I mean, really, if you're not going to test in production, that's the ultimate test. So what about the concept of an outage versus service degradation? What is the difference between the two? An outage means you're down. You are throwing out 500 errors, your application is down, you're not selling, you're not making money. What is a service degradation? It's when you take you a long time to do that. But how do you get there? How do you prevent that? Well, there's a good colleague of ours that unfortunately couldn't come today. He also refers as the clue stick. The clue stick is something that, in his opinion, should be present. Of course, that's frowned upon these days. But anyway, once upon a time, yeah, that happened a few weeks ago. So we were looking at some alerts. There was some service degradation. There was not an outage, but the application was responding a little slow. And if you can see here, the database size was stable. In fact, it was running in RAM. And all of a sudden, we start to see a lot of writes, and the volume nearly quadrupled overnight. So what the hell is going on here? That by itself could mean a lot of different things. But then we took a look at another graph plotted. And that's the proportion of rows being locked on that particular database. And if you take a look here, the times sort of match, and until we actually got to mitigate, the developers to identify the issue and got the developer team to mitigate that. So what was going on here? What was going on here is that the team actually deployed a piece of software and forgot the where clause in an update. So every single update for a single record was actually locking the whole table because all the rows were being affected for that particular operation was an API call. No, there was no data loss. The devices are very smart in that part. They eventually recovered. In fact, it got recovered like 2 hours later. But yeah, so that happened. Another time, this is one of my favorites, we just talked about yesterday. So you have something that is coming from your data lake that you need to feed up to your application because it's a request. Let's say you are a customer service and you need to request something that's available on the data lake, not available on the online database. And that takes a long time. And you say, well, maybe we'll create a projection of sorts to have that updated. Yeah, you have a local copy, refresh it from time to time. Yeah, but that was still slow. So what the hell is going on there, I thought. And so at some point, there was this brilliant idea of adding a cache on top of the cache. And then it was time when we jumped in and took a look at what's going on there. So this is a screenshot. This actually was taken from production. Don't mind all the blurred parts. This is in the hundreds of thousands of rows range. This is a MySQL database. You can see a bunch of things here. First, hundreds of thousands of rows. And then I would like to bring to your attention the fact that they had the primary key and the unique key on the same column, which is sort of redundant. You don't do that. Which is there. That's the primary key was an integer. I have no idea what they did that. There's another problem there. That's a signed integer. Have you ever seen an ID -2? No, you don't do that. You just put that sign there and make it a big integer, so it's 64 bits, it's future-proof, and all that. But the real problem was not that. The real problem is that they were looking for that column, and you don't see an index here, which means the cache that was supposed to speed up things was doing a full scan, CPU-bound, for all the hundreds of thousands of rows every single time it hit. This was taking like 4 seconds to run. Well, once we added an index in the proper time, sub-millisecond range. Yeah, this one actually happened also a few weeks ago. So if you take a look there, that's about an hour and a half. At the time, alerts were popping out for excessive CPU usage on the database. And when we took a look at that, well, that's a 12-table join. It was running on the production database, and of course, we had to kill it. Well, there you go, a quick explain plan of that. But the main problem here are two. First, 12 tables, not good. This is a full scan. This is also a full scan. Again, full scan with no reference, meaning a where clause is missing. We need to start from somewhere. But now take a look at those two big numbers on the columns there. 53 million rows, 14,000. So multiply that by that to actually afterwards be able to evaluate what you're looking for is not great. So a DBA has to step in and do some SQL black magic, meaning taking that humongous query that was built with an ORM. And so what are you guys trying to do that? What you guys are trying to do here? And figure out a way to slice that to minimize impact on the production data. So we turned that 12-table join into something smaller that we could use a pagination technique. Well, basically that ran into a couple of seconds for each range, And this way, you break stuff down, you minimize locking, and of course, you can do that reading from a replica and not locking everything in production. And this is very important when you do 20,000 writes per second, right? Anyway, every millisecond extra that you spend where you shouldn't be costs you in availability. There's any number of ways you can scale horizontally if your workload is mostly reads, but there are limits on what you can do on a single shard. Well, anyway, we're going to talk about that later. About scaling out then, what should we talk about here? This never gets old. Because you develop something, it works great on your computer. And then you go live, like the queries that I sent you, just showed you. We're talking about millions of rows, several 100,000 devices trying to update their data at the same time. So you need to think about that really quick. You need to find out clever ways of doing that. So what is a database? What is a data store? I use those terms loosely because, yeah, it's a place to store data. Plain text file? Yeah, sure, why not? CSV? Yeah, lots of people use that. A spreadsheet, you would be surprised how many people actually store stuff in spreadsheets. I am surprised every day. JSON, YAML, yep, all good. A NoSQL key value, big data, whatever, yeah, sure. Even relational data, yeah, exactly. You have many options there, so go for it. I mean, last time I checked, it was like 7 or 8 different paradigms, not to mention with a bunch of different products. So which one you use? Well, it really depends. Depends on your use case, depends on what kind of expertise you got in-house, and depends how much you're willing to commit to each one of them. With that being said, no database or no data store is perfect. You need to strive or to aim for determinism, and how you do that when your state is constantly changing. If you're doing infrastructure as code, well, that's really relatively easy to maintain so we don't drift apart. But there are a few things that you can do to guarantee or to try to achieve determinism on every single operation. What about concurrency? Same thing that I mentioned before. You got like 20,000 writes per concurrent, or nearly concurrent, because there's no such thing as real time. There's only the illusion of real time. But how do you guarantee that people don't step on each other's feet when they're trying to get into a building? Which brings me to locking. Locking is something really important, especially if you're looking with data, because you can have any number of reads happening on any given data store at the same time. But most of the time, you can only have one writing. So it's better make it fast, make it quick, release it, and do that over and over, thousands of times per second. And then you got I/O bottlenecks, because usually your data is much bigger than you can fit in RAM or caches or anything like that. So be mindful about that. And that is my favorite, because people always overlook that. Backup and recovery. And some of those outages that I'm going to mention are actually related to that. So the goal here is not to eliminate all complexity, but only to keep things as complex as they absolutely need to be. So you're bringing something new to the stack, make sure you write things down first. Because if you don't write, you don't plan ahead, how the hell are you going to know for sure that you got where you were planning to go? Know your stakeholders. That's something that you don't really think when you're in tech. So is it product? Is it the customer? Operations? InfoSec? Service? Support? Database people? Compliance? Maybe you'll have some rules about that. I don't know, depending on the kind of business you are. So just make sure you identify them and make them aware of those. And now we go to the big red flags. Wouldn't it be cool if we add that piece of technology to our stack? Yeah, it would be cool. But the problem with cool is people love to do new things because they're cool. And when they're cool, they want to work with it. And when they work with it and they're in love with it, they lack the skepticism to see how things can break. So let's be careful about that. Remember rule number 3? of the DBA, get used to saying no. That's one of the things. The database is typically a cornerstone of your data infrastructure. You have other stuff, data lakes, ETLs, ELTs running back and forth. Yes, you do. But it's usually based on top of something, and that something traditionally is the database. So with that in mind, not all things are bad. Of course not. The only constant is change. There is new technology coming in every day. But any new challenge, anything you add to the stack must mean something positive for the business growth. I remember when I was in college, Business 101, and they taught me that what is the first and foremost mission of any organization? To stay alive, and then to do anything else. So you don't add stuff because it's cool. You add stuff because it means something to the business growth. There you go, rule number 3. So every time you add something to the stack, it has a cost. It has a cost in time, in people, in money, right? So not just for the engineering team, but the infra team needs to learn about that, especially the on-call people, and we're going to get to that in a few moments. Now back to I don't know what you have on your company is what you do, and that's fine. But something being boring doesn't mean it's not challenging. Let me give you an example. You have a high volume of transactions. That's one thing. You have a critical mission application. That's another thing. Does it need to be cool, or does it need to do the job it's supposed to do? Right, so just keep that in mind. When you do that, you need to find out which metrics are relevant. And although you haven't faced any challenge recently, that doesn't mean that they won't come by. As I said before, the only constant is change, and well, the world is full of examples of that. You need to learn how to tune that, how to respond when something fails. Again, that keyword, not if, but when, because things will fail. And again, the 3 a.m. test. How you're going to respond half awake to an emergency waking you up. And then we go to my favorite chapter, the horror stories. I saw some context here. Right, so everyone heard of that guy, Heisenberg? Heisenberg principle of uncertainty. You can know where a particle is or how fast it is going, but not both at the same time. And this guy probably is more famous a little bit, Schrödinger's cat. Right, there's a nice picture there. The cat is both alive and dead at the same time. And those concepts will be important in the next few slides. So there's a generic story number 1. That's actually happened to me a while back. So I was at a company, I had a very limited budget, and development, production, and testing, and staging, every single thing happened on the same server. What could possibly go wrong? You connect on the wrong socket, on the wrong port, on the wrong, and that happens, you know it happens. If you haven't done that mistake in the past, you haven't learned. Another one, this actually happened a long time ago, was, we had a database, the hard drive crashed. I had no RAID after recovery because we didn't know if the backups were actually working back then. And then we move on to generic story number 3. Let's say your data center burns to the ground, because that never happens, right? Happened a couple of years ago, one famous one, I believe. And your replica on the other data center is out of sync because you don't have enough bandwidth to transmit all the volume of information that you were writing at that time. Your replication was running, but it's just out of sync. But then again, you didn't have enough bandwidth, and you lose data because you didn't have a proper disaster recovery solution. Yeah, this one is fun. It was brought up by a colleague, something that didn't really happen to me recently, but this maintenance job that was running for weeks, trying to fix patch some data, backfill some logs, and remove some older information. And it was running for days, which means that your backups are running perfectly. But that's not the problem. The problem is that was running for days, deleting data that was once in production and changing things. You only notice when it's too late. What is missing? That is very tricky. Most common with ad hoc, one-time operations, so let's just review the whole thing before it gets to production. Because needless to say, recovery is a pain. You need to take multiple sources of truth to rebuild your data, like logs, text logs, and all the operations that you had stored during that. Which brings me to the GitLab incident on the 31st of January 2017. This is a very, very, very oversimplified version. Bear with me. Basically, an engineer deletes the entire production database. It starts with that. All right? It was an 18-hour outage, and there was data loss. Not all of it, but partial data loss. Again, oversimplified, bear with me. There's an actual article with the postmortem published, and if you Google it up on YouTube, you can find a video with the short version. Long story short, the database was writing too much, too fast, and at some point they needed to make sure that the replica was up and running. For load balancing purposes, for DR purposes, I don't remember the context right now, but that's not important. Important part is, in order to keep the primary running at all costs, they were limiting the amount of walls or write-ahead logs that were allowed to be kept on disk, so it didn't run out of this space. But since those walls were not getting in fast enough to the replica, it became out of sync. So what you do, you take your backup, and in order to recover that, I believe they were using bare metal machines or VMs, but it was not a managed service. It was directly on the shell. So you destroy your data directory too. You can load that up from a backup. They removed the wrong database. They logged into the primary and wiped it out. And of course, that happened. That actually happened. So by that moment, they didn't have a secondary or a replica. But remember, they were trying to rebuild the replica and destroy the primary. They had no volume snapshots. Yes, they were taking backups, but they were failing. And they were not getting neither the success or failure messages that they should be getting. So, yeah, kind of important, at least to know if it's failing. So they ended up restoring from staging from a different region. It took a long time because their storage, they were not on premium storage. It was in lower tiers, so it was slower. And they had Heisenberg recovery procedures. I mean, uncertainty by definition. They had never tested that, so it took 18 hours to come back online. Final remarks, if we're good. That also never gets sold. All modern infrastructure hinges in a little bit of code there or a little piece of infrastructure. Identify that. You can say that about US East 1, right? And what else? Do you have a dependency to another data center or to some SEGLI legacy service? What if your ISP burns to the ground? Do you have redundant connectivity to that? VPNs, anyone? You know, or you have a single legacy service that depends, everything hinges on that. What happens if that starts to time out? What happens to your online application? What about that tractor that dug a hole by the side of the road and ripped all the fiber optics from a place to another? Those are all real stories. Don't be that person. Don't be the person. That's a bad place to be. Don't push stuff up the hill. Try to treat tech debt as a loan. Keep it in check. Pay it regularly, otherwise it will eat you up. And don't let it get to that. When you're talking about engineering solutions for a problem, stick to that and think always about the business, what's best for the business. Lesson to learn here. Architect for peer demand, always. Think about the worst, absolutely worst case scenario. Identify your single points of failure. Could be more than one. Make your alerts meaningful, especially for the 3 a.m. test. Backups, I cannot say enough. Do your backup reviews and do them often. A backup that has not been restored is no backup at all. If you haven't tested it, it's not a backup. Have a single pane of glass, one you can quickly identify and correlate metrics that otherwise you won't be able to do. So this is graphic from peak demand from Bloomberg. This is a retail company. I don't remember what business they are, maybe cosmetics. But that's a peak demand. And the following year, even higher. So I heard of companies that have single monolithic databases that actually shut them down a few days before, scale up on a bigger VM for those events, and then shut them down again. Well, that's one choice. That's the way I would do it, but hey, sometimes technology is what you got. Identify your single points of failure. Could be, that legacy service that no one remembers where it is or where it lives. And then test. Test to exhaustion. Test more. Test even more. And then you go to real workloads, as real as you can get, but you cannot get any more real than production. And just making sure that you actually understand what are the implications. Then let's go to having meaningful alerts, and I'm going to give you a few examples of what we have right now in our infrastructure. Make sure your metrics are meaningful. Provide hints and tips with what's going on for engineers to pass the 3 a.m. test. I cannot stress this enough. Don't be in a situation where the only person that actually knows what's going on is on holidays, on the other side of the planet, with no access to the internet. Let them rest. So take this one, for instance. This one is about something that we were able to spread in a database cluster with decoupled compute from storage, so we can add nodes on demand. But this is the hint. This is not an outage. This is an alert letting you know that we are at our current capacity. If a node fails, we will be in trouble. So if you're in a critical position of sales of the year, add another node. Just that. It's a preemptive alert. Another one. So this one, we don't do it anymore. Burstable instances in production, but this tells you, hey, maybe you could add another node or take a look at what's going on before you actually dive into an outage. This one is about serverless databases. It's one solution, but it lets you know that the capacity that you are dedicating, where upper capacity is getting to a limit, maybe you want to add more nodes, maybe you want to review that. That's not an outage, but you're walking into a service degradation soon enough. Yeah, right. So this one is actually not an outage, but it speaks to service degradation. When you have a humongous amount of writes going into your server and you start to see latency of your commits increase. And that can have all sorts of effects, especially if you need or require strong, consistent reads from your replicas. Oh yeah, just pretend there's a D there, because I forgot when I wrote the alarm. This one is actually, we set it up. We had to set it up. And the cue here is, since we have a multi-master, a multi-writer approach, sometimes failovers can happen. And when those happen, the application, what they do? They reconnect. So they were there in their pace, and all of a sudden, oh, I don't have my writer anymore. I need to reconnect. And all of a sudden, you can have that. So write on your alerts stuff what the engineers should be doing to check. Backups. I cannot stress enough about backup procedures. Think about your recovery point objective, which is how much data you're willing to lose. Think about how much time you are going to get there, because it's not just about that. An outage can last for several hours if your recovery actually takes a long time. And make sure they are tested at least once or twice a year. Make sure the procedure for recovery works. And make sure you have procedures. Test, rinse, and repeat. Then you got a single pane of glass. These are 3 very busy databases, 3 different clusters, and from Auroras, MySQLs, and Postgres, and things like that. Just make sure you have something like that. Woohoo! We made it with 5 minutes to spare, and at this moment, I'd like to call my team here to the stage. You guys, yes, you, come on. I'd like a picture here, if you don't mind. Oh, that's part of the team? Yes, you. No? All right. So that's part of the team that's sitting right there. Come talk to us if you want. And I guess we have some time for questions.
Yeah, first of all, on behalf of everyone working in this industry for so many years, thanks for this talk, because these talks are really necessary, so thank you. And beyond that, yeah, I mean, there's a very good one here, because it's something I've never managed to do properly. So if you have any recommendation on how to generate real production-like traffic, because effectively with databases, it's even more complicated because you need to deal with the inside caching mechanisms, all that sort of stuff. So if you can provide anything insightful at least.
Well,
yeah.
Mimicking production traffic is always difficult for many reasons. First of all, you test randomized data, not actual data. Second of all, you don't have real-time latency over there, and you do not want to have traffic generators on top of data. So one way to do it would be to mirror whatever you're getting from production and hitting that second copy of the infrastructure at the same time. You just intercept the request, make a mirror request that doesn't actually make to the public. So that's one way of doing it.
Yeah, that's one strategy I took in the past. Yeah, thanks. Yeah, there's another one which maybe is more about, inter-teams management. Like, how do you balance all these things with, development empowerment, which is maybe something we shouldn't do as we do that much, but yeah, it's always, there's this balance, right? So is there any committee you decide together, like some sort of strategy you can share?
Well, it depends on your business, how you're organized, but the most important part is to realize that, make everyone realize that teams don't work one for another. There's not like a hierarchy, but as soon as you get to your people to realize that you work all together in the same boat, the better. So that's my strategy.
Yeah, cool. And any strategies to deal with tech debt? Because you shared that story with the primary keys which were signed and all that, but it's not that easy to do an alter table, right? Depending
on your technology, it's not that easy. But at the same time, you can mitigate that by having a migration happening in multiple steps. Some other time we used in Amazon, we used blue-green scenarios. Before that, a while back, I used to have physical servers, which you could really just spin up a copy of it. You can use LVM snapshots if you are in a shoestring budget, which already actually use that to spin up dynamic environments for developers.
And final one, which is kind of fun, like some people are surprised that relational databases still exist. Anything else you want to say about NoSQL databases? We've ranted a lot.
Well, I'm going to say that relational databases are not going away anytime soon. There will be a lot more technology. There is a lot more technology coming on to the stage every single day. I will say that sharding is here to stay. If you want to you want to scale, you really need to look at spreading your application. Dividing your monolithic application in several smaller monoliths is, well, I guess it's a start, but doesn't really remove your problem in the first place, which is concurrency and locking. The only way to do that is to spread it between multiple nodes.
Okay, so please, every single one of you, on Monday, don't propose any Neo4j database before thinking about it. Thanks a lot, Augusto.
Thank you
very much.